Okay, so everybody should have their headset. Everybody should be sat down on a chair. Now, the first thing to note is you've got amazing wheelie chairs for one really, really good reason. And that's because when we start looking at things through our VR headset, when we start our journey, you'll be able to see things in all directions. So you'll be able to look up, you'll be able to look down, and you'll be able to look in 360 degrees, okay? They've got wheels, although they're not bumper cars, okay? So we don't want to see anybody bumping into each other. You don't need to be moving around other than spinning. So make sure you spin as much as you want to, but other than that, we're not moving around. Now, you're in for a special treat this morning. We've got some very, very amazing technology, courtesy of these lovely people here from VRX1. And what we're going to do is we're going to go on a bit of a journey into space. Okay, so very, very exciting. Now, if your eyes start to hurt at any point, or you do start to feel a little bit dizzy or anything, just take the thing away from your eyes for a minute, let your eyes rest for a few minutes, and then you can carry on. Okay, so if you have any problems with it, if it's not working how you think it should be at any point, just pop your hand up and one of the lovely people will come around and help you straight away. Okay, are we ready to get going? Yes.
What does this button mean?
That button opens it, but you don't need to be pressing that button. Okay, so that opens it. Inside there is a mobile phone, but you don't need to press that button because it works much better when they stay closed. Okay, let's go. Control it, and then you've got like information stuff as well, and you can like point to bits of places as well. So this is what they're seeing. And these faces are where they're looking, yeah. So if you, I'll show you in a minute, if you press on something, then they all look at it. It's pretty cool. Okay, 3, 2, 1. Okay, excellent, year 4. That was really good. When you hear me counting down like that, it's because I want everybody's attention. It might be because there's a really, really cool piece of information I want to share with you, or a question I want to ask you, something like that. And obviously when I ask a question, want lots of hands up, unless I say shout out the answer. Sometimes I might want you to shout out the answer. So first of all, we'll start off with the shouting out the answer. Where are we right now?
Space.
Fantastic. Anyone be a bit more specific than space?
Mars.
We're not on Mars, no.
So we're kind of in a no gravity area with no area. So we're kind of like in the Milky Way because
We are in the Milky Way, good, but even more specific than the Milky Way.
the galaxy.
Even more specific than the galaxy, yes. Well done, we're in the solar system, okay? Now, our solar system is our neighborhood of space. It's our little bit where we live. And it's a big collection of planets, some smaller objects, dwarf planets, lots and lots of moons, 170 moons in fact, and the most important thing, the sun, which is our one and only star. So first of all, just direct your attention to the sun. So the first thing you may have noticed is just how big and how bright the sun is. Now the sun is absolutely huge, far too big for us even to comprehend. It actually takes up 99.9% of all the mass of the solar system. That's how big it is. So it's so much bigger than all of the other planets combined. They're so tiny compared to it, which I'll be able to show you a little bit later. Yes? That's an excellent fact. Do you know how many Earths it can hold? Well, we'll find out later on. Okay, now, can anyone put their hand up and tell me what planet that is just there? Yes, young lady at the front just here. Well done, it is Mercury. Now, Mercury is the closest planet to the sun. And being so close to the sun, it is very, very hot. But it's not actually the hottest planet. A lot of people think it is the hottest planet. But does anyone know what the hottest planet actually is? It's not Jupiter. It's not Mars either, no. It is Venus. Well done, good boy. Now the reason why Venus is hotter is because Venus has a different atmosphere. It has an atmosphere that's made up mainly of carbon dioxide. And carbon dioxide is the air that we breathe out. It's the gas that we breathe out. It's the one that we don't need for our bodies. But because the atmosphere is mainly carbon dioxide, it traps all the heat on the surface of the planet, making it extremely hot. It'd be far too hot for any of us to go there. And there is Venus just there, the second planet from the Sun. And it's actually one of the closest planets. It's the second closest planet to Earth, and it's more or less the same size as Earth. But because of that atmosphere, there would be no chance of us being able to live there. Now, no prizes for guessing what this planet is right here. It is indeed. Now, obviously, Earth looks very different to the other planets, and the main reason for that is it has an atmosphere and it has water on the surface. And water is the one thing that means that we can live on this planet. It's the thing that all living things need in order to be able to survive. Now, although it looks quite close on your image that you're looking at the moment, it's actually really, really far away from the Sun. It's actually 90 million miles away from the Sun. So it's a long, long way away. And every time you see a ray of light coming in through the window in the morning, that light has traveled those 90 million miles, and it's taken it 8 minutes to get here from the Sun. So it's taken a long time for it to arrive as well. That's how far away it is. Okay, can you shout out this one for me? What's this planet just here? Okay, well done. You can see we've got a very bright group of Year 4s this morning. Now, Mars is often called the red planet. We call it the red planet because it appears red to us in space because of the dust colour of the surface. Now, we've been obsessed with Mars for quite a long time, actually, as a culture. For a long, long time, we were obsessed with the idea that there might be little green Martians running around on there who might one day be our friends and come and say hello to us. And in a lot of stories and things like that, there are Martians. Sometimes they might be evil, sometimes they might be friendly. And we've been obsessed with it for quite a long time. And we're kind of really obsessed with Mars again at the moment because there's a big competition going on at the moment to see who can be the first people to actually go to Mars. And a lot of companies are planning in the next 30 years to be able to get people to set foot on Mars and even live on Mars because it would take so long to get there. And you guys are the sort of age, could be when you're the same age as me and Mr. Catchpole, could be that people are off on their way to Mars to go and live there. So that's really, really exciting. Yes?
So, Mars is kind of the red planet because why can't we could come there right now, but how are we going to survive all the conditions?
That's exactly.
Raining acids, second millions of giant volcanoes, sort of all coldness, brain freeze, and popping.
Exactly, Maz. And you know what? We're going to have a look at that exact thing a little bit later. We're actually going to go onto the surface of Mars a little bit later. So you can tell us all about those challenges just then. Okay, now, the next planet, our fifth planet from the Sun, is also our largest. Can anyone put their hand up and tell me what this one is called? Yes, young man at the front, Leon. It is Jupiter, well done. Now, Jupiter is known as a gas giant. One, because it's so huge, it's the biggest planet by a long way in our solar system, much, much bigger than Earth. And also because it's primarily made up of lots of gas. And you can see there, it looks quite beautiful on the surface of it, those swirling marbly patterns. But those swirling marbly patterns are actually giant storms that are raging on the surface. And some of them have been raging for hundreds and hundreds of years. Really, really angry, violent hurricanes and tornadoes. So it wouldn't be the nicest place for a day trip. So our next planet along the seventh planet is Uranus, and it's actually a very, very long way away. So we're getting further and further and further away from the Sun. And Uranus is so far away, it actually takes it 84 Earth years to travel round the Sun. So it's 84 times far away as Earth from the Sun, so a very long time. And finally, our lovely eighth planet is Neptune. Okay, well done, sorry if you put your hand up for that one. And Neptune is the farthest planet away and is also the coldest by a long way because it is so far away from the heat that the Sun provides. And it has an average temperature on the surface of minus 360 degrees. That's just how, put your hand down for now, that's just how cold it is. Okay, we're going to continue our journey. So, some people said we're in the solar system, some other people said we were in a galaxy. Okay, just stay in your seat. Just stay in your seat, Leon. No.
How do you have image of the Milky Way?
Very, very powerful satellites with big telescopes, cameras. Okay, guys, sit down.
Black holes are made out of dead stars.
It is. Okay, take a seat. Okay, 3, 2, 1, 0. Okay, just try and stay in your seats for me, please, just because these are very, very expensive headsets and we wouldn't want them getting damaged. Now, a lot of clever people at the start also told me not just that we were in the galaxy, but also the name of that galaxy. And the name of that galaxy is the Milky Way. And you can see the Milky Way just there. That's what we're looking at. And we're looking at a collection of lots and lots and lots and lots of stars. Now, every class I've tricked with this one so far, so we'll see if this class can get it right. I've got a feeling that you might do. How many stars are there in our solar system? Nope. Nope, much less than that. How many stars are in our solar system? Nope. Mazin?
There is kind of one because the sun.
Exactly, well done. There is only one star in our solar system. The sun is our star. And all of our planets revolve around that one star. Now, in the Milky Way, in our galaxy, there are 200 billion stars. So if you imagine the sun, and we just saw how big the sun was and how important it is to us, that's just one of 200 billion. And if you want to feel really small, our galaxy isn't the only galaxy out there. Our galaxy is just one of 100 billion different galaxies. So that means, no, Mazim, you need to be listening. That means 200 billion stars in 100 billion galaxies. You've got an awful, awful lot of space out there, which we haven't really started to explore. Okay, now, we've traveled through space already, also now going to travel through time, so get ready for this one. Fun, isn't it?
Doing this same speech all the time.
Pretty much.
Because they can.
Ad-libbing as I go. Leon, stay in your seat for me, please. My favourite bit is when they point in different directions. They're like, look over there. Okay, 3, 2, 1, 0. Okay, now, a lot of other classes have gone straight away, oh, that's so cool, that must be a black hole. It's not actually a black hole. Can anyone put their hand up and tell me what they think we might be looking at right now? Yes, Matthew. It is the Big Bang. Well done. Can you explain for us what you mean by the Big Bang? Brilliant. Yeah, very, very good explanation. For a long, long time, people didn't really know how the universe was created, but some very clever scientists, some astronomers, people like Copernicus, Galileo, Kepler, Isaac Newton, have discovered that they have a theory that the universe and our solar system were actually created in a big bang, a big explosion. And what we're looking at right here, that right there is the very birth of the sun. So that is the sun being created by a very big explosion. I'm just going to fast forward time on just a little bit. Stay in your seat, Mazin. No, you need to stay in. Yep, you need to stay in your seat. Too excited. Okay, 3, 2, 1, 0. Okay, so what we are looking at just here, now when you wake up in the middle of the night and you need to be able to see, you turn a light switch on and your light switch is on. What we're having a look at here is the sun turning on for the very first time. So this is when the gases inside the sun ignited and they've been burning ever since. So that bright light you can see, that is the very birth of the sun. And you can see a couple of planets around. You can see Jupiter, you can see a couple of shooting stars, some stars in the background. But most of what you can see, those rocks, that is what's going to form together to create the planets that we know and the moons that we know, including our very own. Okay, now, just going to go back to our solar system, how it looks now. We'll talk about Pluto in a minute. Sad, sad Pluto. Okay, 3, 2, 1, 0. Now, a long time ago, people used to think that the Earth was the centre of the universe and the Earth was the centre of the solar system and everything else moved around. Because we can see the sun move across the sky, everybody thought that the Earth stayed in one place and everything moved around it. However, some very clever astronomers, again, Nikolai Copernicus and Galileo Galilei, actually discovered that it is the sun stays in one place and it's the planets, including the Earth, that move around it, and they do so in an anti-clockwise way. And you can see the path that each planet takes there in those blue lines as it moves round. And the time it takes a planet to do one complete journey of the sun is where we get a year from. So a year on Earth is 365 days. It's actually 365.25 days, because that's how long it takes for the Earth to do one complete trip. Now, some of the planets have much shorter years because they're closer to the sun. So Mercury, it only takes 88 Earth days for Mercury to travel around, so it has a much shorter year. But Neptune, poor old Neptune, right out on the edge, has got so much further to travel, it actually takes Mercury 165 Earth years just to do one trip. So 1 year on Neptune is equivalent to 165 years on our planet. Takes a long time. Now, something else you might be able to see if you look very closely. If you look at Earth, it's got its own little blue line going around, its own little blue circle. Can anyone guess why that might be? Matthew? It's the moon. Now, the moon is interesting because the moon, we can see it in the sky at night time. It orbits the Earth. So it doesn't orbit the sun, it goes around the Earth. If you look closely at Mars, you might be able to see it's got two little blue circles going around it. Why do you think it might have two little blue circles? You want to have a guess? No, it's not the rings. It has two moons. Well done. So Mars actually has two moons, so you can see those going around. Now, if Mars has got two circles because it's got two moons, what do you think is going on with Jupiter? How many moons might Jupiter have? It's got a lot, hasn't it? If you look at Jupiter and Saturn, it's got lots and lots of moons, all orbiting round all the time as they go. Okay. Time to move on again, back to our lovely planets.
Neptune looks close to the sun though.
I know. Okay, so this isn't actually how the planets are positioned, but this gives you a nice close-up look of each planet. And these are based on very high-tech camera pictures of each planet. So it gives you an idea of the surface of each one. Now, nowadays we have 8 planets, but when me and Mr. Catchpole were at school, there were actually 9 planets. Does anyone know why? Because of Pluto. Well done. Now, poor little Pluto, which was actually our furthest planet away, it was just past Neptune, was declassified as a planet, unfortunately. Because it was so small, it was actually deemed to only be a dwarf planet, so it doesn't count for a real planet anymore. Sad times for Pluto. Okay, time to move on. Still there? Yep. Okay, 3, 2, 1, 0. Just waiting for a couple of people. Well done, you thought. Okay, so I heard quite a few people say there, almost as soon as I flicked onto this one, a few people go, wow, look how big the sun is huge. And you're exactly right. This picture we're looking at now is the planets in perspective. So that means that's how big they are compared to each other. And you might notice straight away just how absolutely huge the sun is compared to our tiny little Earth, which is only a tiny little circle on there. And Mercury and Mars are even smaller. So you can see just how big the sun is. And in fact, the sun is 109 times wider than the Earth, and you could fit 1.3 million Earths inside the sun. That's how big it is. So it's 1.3 million times bigger in volume. You can also see there that Jupiter and Saturn are much bigger than our other planets. So Jupiter compared to Earth again is absolutely huge, but nowhere near the same kind of size as the sun itself. Now, one final look at our solar system before we move on. Okay, 3, 2, 1, 0. Archie, thank you. Okay, so this is a picture of our solar system taken from a very, very long way away, taken from a satellite a long way outside our solar system. And you might notice a few things. The first thing you might notice is the distance of the planets from each other. Another thing you might notice is that circle of rocks that goes round the sun and seems to separate Mars from Jupiter. Now that is what is known as the asteroid belt, and that basically is a big ring of rocks floating in space, and it's actually really important for Earth. It does a really important job, and the job that it does is it protects us. It's almost like a shield of rocks from lots of other meteors and asteroids and things that might come and crash into our planet. So it does a really, really good job of defending us. Now, if you look further out as well, all the way past Neptune, you can see little Pluto there. You can see how small it is. It's in fact not that much bigger than our moon. So it's much smaller than all of the other planets. Okay, so one of the reasons we know so much about our solar system is because of a very, very special thing, which is currently floating around in orbit around our planet. So, welcome to the International Space Station. same. You have to have a rest every now and again. You have to have a rest every now and again. Okay, 3. Leon, sit down for me. 2, 1, 0. Okay, so we are now on board the International Space Station, which is a big collaboration between lots and lots of different countries who wanted to find out more about space. And they made it possible for astronauts and scientists to actually live in space. So they're living in orbit around our planet. Now, the reason why the International Space Station is so important is because of all the experiments they do on board. Because they can do lots of experiments that you wouldn't be able to do on Earth. Immersive learning offers huge benefits because it enables you not only just to tell children about things, but you can actually jump inside them and actually show children and actually demonstrate various things, particularly useful for things where they wouldn't be able to do it. So jumping into space, jumping into the middle of a volcano, you just wouldn't be able to offer that anywhere else.